Hello, everyone. Today, we're going to do packet tracer of SRWE 2 version 7.3.1.4 packet tracer. Who hears the broadcast? Objectives: Part 1, observe broadcast traffic in a VLAN implementation. Part 2, complete review questions. Scenario: in this activity, a 24-port 2960 switch is fully populated. All ports are in use. You will observe broadcast traffic in the VLAN implementation and answer some reflection questions. So on the left side, in this topology, in the middle is a switch. It is a 2960 layer 2 switch. This switch has 24 ports. So each port is connected to a PC. So there are totally 24 PCs are connected. And these 24 PCs are evenly splitted into 3 groups or 3 VLANs, VLAN 10, VLAN 20, VLAN 30. And each VLAN has their own IP address range for the PCs. And we're going to observe the broadcast traffic in the VLAN. And here, instruction step 1, use ping to generate traffic. PC0, okay, go to PC0, desktop, command prompt. Here they ask us to ping an IP address, which is 192.168.1.8 ping 192.168.1.8 ping. Yeah, the ping is successful because this PC0 is in VLAN 30, and this IP address 1.8. From here, the 8. It's so both PCs or both IP addresses are in the same VLAN 30. So the ping is successful. Unlike LAN, a VLAN is a broadcast domain created by switches using packet tracer simulation mode. They ping the end devices within their own VLAN. Based on your observation, answer the questions in step 2. Step 2, generate and examine broadcast traffic in the VLAN implementation. Switch to simulation mode. Yeah, currently we are in the real-time mode. It is a default mode. Now we need to switch to a simulation mode. So click simulation. Here's the simulation panel. Event list is empty right now. And click edit filters. Edit filters is here. So here. And show all or none. So now it's none. No protocols or no applications are selected. So click it, click. So click all. So all the applications or protocols are displayed in this window. And here's all the protocols are checked. In the checkbox, all checkboxes are checked. All right. Then show none. So no, none, check, all, none. Okay, so here we need to check ICMP only. So ICMP is in the IPv4. So ICMP, click it. So close the window. So ICMP is displayed in this window. Okay, become the visible event. So now we need to go to add a complex PDU. Add the complex PDU. PDU is protocol data unit. So here, this envelope, open envelope icon is add complex PDU. Click it. Then the pointer or the mouse cursor will change to an envelope with plus sign. All right, so go to here. And click PC0. So PC0 will become the source of the packet. Because we're creating a broadcast packet. So here we're going to the setting. Source is PC0. The destination IP address should be the broadcast IP address, which is 255.255.255.255. Sequence number is 1. One-shot time is 0 second. And here, select application. Here we use ping. Okay. And there's a question. What are at least 3 other applications available for use? So here there's a down arrow. Okay, the scroll down list. In order to answer this question, you just pick up any 3 of these application and put to here to answer. Any, the DNS, FTP, HTTP, whatever. You can pick 3 of them. So this is my answer. Okay, I pick up SSH, FTP, HTTP. Okay, then create PDU. Create PDU, the test broadcast packet now appears in the simulation panel event list. Let's create PDU. Okay, so here is the simulation panel. So this broadcast packet appears here in the event list, ICMP, but this packet is broadcast packet. Okay, it also appears in the PDU list window. Where is the PDU list window? It is the first PDU for scenario 0. Okay, so here, let me expand this window here. So here on the right corner, bottom corner. So here, here's a scenario 0. And this toggle. Toggle PDU list window. Here's the PDU list window. So let me close it. I only use the simulation panel. All right, so here's the scenario 0. Then they ask us to click capture forward button twice. Okay, let's watch here. This is the capture forward button. This is capture forward button. You can click either these 2 buttons. So here is a broadcast packet on PC 0. Click 1. So this packet is sent out from PC 0 to switch. Then click again. All right. So the switch forwards this broadcast packet out to all the other PCs in the same VLAN 30. So all the other 7 PCs receive this broadcast packet, except the PC 0, because PC 0 is where the packet comes from. Okay, let's answer the question. What happened to the packet? The answer is the broadcast packet was sent out to all other 7 PCs on the same VLAN 30. Here is my answer. Okay. So all the broadcast packet was sent out to all other 7 PCs on the same VLAN 30. Okay, next is repeat this process for PC 8 and PC 16. PC 8 is in VLAN 10. PC 16 is in VLAN 20. Let's go to do. Okay, so let's close the packet in VLAN 30. So we delete here, delete. Don't forget scenario 0. Delete, okay. So this time we will create a broadcast packet on a PC 8 in VLAN 10. So this open envelope icon, click add complex PDU. The cursor change to an envelope plus with plus sign. Click PC 8. This is a source. The destination IP address is the broadcast IP address, which is 255.255.255.255. Sequence number is 1. One-shot time is 0 second. And the pin, select the application, create PDU. All right, so this broadcast packet is created on PC8. Let's click the capture forward button. So this packet is sent out from PC8 to switch. Click again from switch to all other PCs in the same VLAN. Yeah. And I delete this packet. And let's repeat. Let's repeat on the PC16. Okay. PC16 becomes the source. Destination IP address is 255.255.255.255. Sequence number is 1. One-shot time is 0 second. Pin, select application, create PDU. So broadcast packet is created on PC16. So click capture forward button. So packet is sent out from 16 to switch. Click again from switch to all other 7 PCs in the VLAN 20. Okay, we finished this. Okay, next is the reflection questions. We need to answer all these 8 questions. There are 8 questions. Okay, the first, if a PC in VLAN 10 sends a broadcast message, which devices receive it? It's very simple, right? All the PCs in VLAN 10. Okay, here's the answer. All PCs in VLAN 10. If a PC in VLAN 20 sends a broadcast message, which devices receive it? All the PCs in VLAN 20. It's very simple. If a PC in VLAN 30 sends a broadcast message, which devices receive it? All PCs in VLAN 30. Okay, next question is what happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 30? A PC from VLAN 10 sent a message to a PC in VLAN 30. So these 2 PCs are in different VLANs. It's a unicast packet. Let's create a unicast packet to see what happened. So let's click delete this packet. The unicast packet is here. This envelope. This add simple PDU. That's a unicast packet. So I pick up any PC from VLAN 10. I pick up PC 15 as a source. Destination is PC 7 in VLAN 30. Okay, and see what happened. Let me click the capture forward button and wait a little bit to see. All right, so here the flash, the red cross, that means this packet cannot send out. Cannot send out from PC 15 to PC 7 because these 2 PCs are in 2 different VLAN. So here, what happened to frame? Yeah, the answer is here. The unicast packet will be dropped. In other words, cannot send out because these 2 PCs are in 2 different VLANs. Next, 5. Which ports on the switch light up if a PC connected to port 11 sends a unicast message to a PC connected to port 13? When ports light up, that means that these 2 PCs that are connected to port 11 and 13 can communicate each other, and their communication is successful. So from this activity, this packet switch activity, we know that these 2 PC have to be if these two PCs wants to be communicate each other successfully, these two PCs has to be in the same VLAN. So in other words, these two ports that are connected to these two PCs should be in the same VLAN as well. So if these two ports are in the same VLAN, the PC can communicate and the ports will light up. If they are not in the same VLAN, the ports light will be down. So let's check if these two ports, port 11 and 13, are in the same VLAN. Let's point this PC. All right, so point the PC, okay. Port 11 and port 13, okay, here, port 11 link up, VLAN is 20, 13 is up and 20. So these two ports, port 11 and 13, are in the same VLAN. That means the PCs connected to these two ports can communicate each other successfully. So the ports will light up. The answer is here. All right. So because both ports 11 and 13 will light up because they are in the same VLAN 20 or in the same network. Next question, which port on switch light? If a PC connected to port 2 sends a unicast message to a PC connected to port 23, yes, same way, we have to check if port 2 and port 23 are in the same VLAN or not. If they are in the same VLAN, the ports light up. If these two ports are not in the same VLAN, the port light will be down. So let's point this cursor to the switch. Then you'll see port 2 and port 23 this time is port 2 is in VLAN 30. Port 23 is in VLAN 10. So these two ports are in two different VLANs. So the PC is connected to these ports cannot communicate each other. So the ports will, port light will be down. All right, so here's the answer. So no light will be up. The unicast port will be dropped. Okay, because the port 2 and port 23 are in different VLANs. The last two questions. In 7, in terms of ports, what are the collision domains on the switch? Collision domains on the switch. What are the collision domains on the switch? Collision domain is where a collision can happen. Basically, collision domain occurs on layer 2 switch. Specifically, a collision domain occurs on the ports of the switch. That's because the switch communication works on the shared media. They share the same bandwidth. So when two devices are trying to communicate at the same time, a collision will occur. So that's why we use full duplex to help eliminating the collision. Full duplex is 2 lanes, one for sending information, one for receiving information. So under the full duplex, the sending information and receiving information on a port can happen at the same time. But if a port is set half duplex, the receiving and sending cannot happen at the same time. One of them have to wait until the traffic is clear. So the traffic speed will slow down. So every port on switch, every port is a collision domain. So let's go back to the question. What are the collision domains on the switch? So the collision domains on the switch are the ports. So every port is a collision domain. So here, this switch has 24 ports. That means this switch has 24 collision domain. Okay, here's the answer. Each port is its own collision domain. 24 ports have 24 collision domain. 8, the last question. In terms of ports, what are the broadcast domains on the switch? Broadcast domains on the switch. A broadcast domain is where traffic is allowed to flow all over the network. So from this activity, we can see that each VLAN is a broadcast domain because a broadcast packet can flow over the whole network to all the other PCs through switch. So each VLAN is a broadcast domain. Here there are three VLANs. So there are 3 broadcast domains. Actually, VLANs act as a LAN segment. VLAN reduce the incidence of collision, and in the meantime, decrease the number of network resources wasted. So we finished this packet tracer. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel, share with your friends. See you next time.